Welcome to section 14.2. This is vector field examples. So let's suppose that we have the vector field negative 2x over x squared plus y squared squared, comma negative 2y over x squared plus y squared squared. And we're looking to find the divergence of curl of this particular function. So let's rewrite this vector field f as negative 2x parentheses x squared plus y squared to the negative 2, negative 2y, x squared plus y squared to the negative 2. And I will be using the property that these are symmetric functions. And so when I know something about one function, I'm going to know something about the other function. So my divergence piece, when I'm looking at my divergence of f, I'm looking for the partial with respect to x of the first piece plus the partial with respect to y of the second piece. So I'm looking at the partial with respect to x. This is a product rule, so I do the derivative of the first, negative 2, times the second piece, plus the derivative of the second, so negative 2, x squared plus y squared, negative 3. Chain rule says 2x, and that's in my parentheses. And so this simplifies here to be negative 2, parentheses, x squared plus y squared to the negative 2 plus, and then we've got negative 2 times negative 2 times 2, so that gives me 8x squared plus y squared to the negative 3 power. And I know that this is going to be the same piece for the other function with respect to y because of symmetry. So plus negative 2 x squared plus y squared, negative 2 plus 8, the difference being y squared, x squared plus y squared to the negative 3. Simplifying this, I have an x squared plus y squared term, an x squared plus y squared term here to both the negative 2 power. And I've got some factoring that I can do. And doing my factoring and some canceling out, I see that I can get 6 over x squared plus y squared, quantity squared. And this is my divergence for my function. So now for my curl of my vector field, I'm going to use a property that my curl is equal to nx minus my, using the trick from earlier. So the derivative of the second term with respect to x, the derivative of the first piece with respect to x is 0, so that's just a constant with respect to x. So I can think of this as just a constant, and I'm just looking at a chain rule. So I have 4y times x squared plus y squared to the negative 3 power times 2x minus, and the same property goes here. Sorry, lost my negative 4 here. Negative 4x times x squared plus y squared times negative 3 times 2y. And I see that these terms are identical, so my curl here is 0. So my divergence here is equal to 6 over x squared plus y squared plus squared, and my curl here is equal to 0 for my field. So I have some divergence, I can compress my field, but my field has no rotation. So let's suppose I'm finding the divergence in curl where I have a vector field given by a potential function, x squared plus y, or excuse me, x squared times y. So the first thing I need to do is find my vector field. So I take the partial with respect to x and the partial with respect to y. So phi sub x, when I look at this here, so the vector field is phi x comma phi y. So phi sub x is equal to 2xy. Phi sub y is equal to x squared. So now I have my vector field, so I can find my divergence in curl. So my divergence of f, I take my vector, the partial with respect to x of the first component is 2y, plus the partial with respect to y of the second component is 0. So my divergence is equal to 2y. And now my curl of f, I can use again the same property, nx minus my. The partial with respect to x of my second component is 2x, the partial with respect to y of my first component is 2x, so this gives me 0. And this is in the z component. So technically, my curl is a vector because it's a cross product. So my curl would be equal to the 0 vector. And again, that would be equal to the 0 vector up top. So now let's take the same vector field as we started, but let's add on sine of z. So let's let phi of x, phi be x squared plus y, x squared times y plus sine of z. So our vector field f is 2xy, comma, x squared, comma, cosine of z. So our divergence of f becomes 2x, or sorry, excuse me, 2y plus 0. And the partial with respect to this, so minus sine of z equals 2y minus sine of z. So our divergence is easy to calculate. And now our curl of f, we have 3 components, so we can use our cross product formula. So we have our I, j, and k notation. We have our partial with respect to x, our partial with respect to y, and our partial with respect to z. 2xy, x squared, and cosine of z. We're taking the determinant of that. So we had the partial with respect to y of cosine of z is 0. Partial with respect to z of x squared is 0. So our first component is 0. Negative the partial with respect to cosine of z is 0. Partial with respect to z of 2xy is 0. So our second component is 0. Partial with respect to x squared, excuse me, is 2x. Minus partial with respect to y of 2xy is 2x. So again, we get the 0 vector. So we have no rotation in our system. So as always, if you have any questions, feel free to let me know.